viewers, welcome to Botany Point. Today in this video I am going to talk about mechanism of stomatal transpiration. This part 1 video of mechanism of stomatal transpiration already uploaded. This part is part 2 video where I am going to explain the processes how the water removes from the stomata. So the three processes are important which helpful for the removal of water vapor from the lips to atmosphere. Okay, so this process is first three important basic thing, that is first one is diffusion, second one is osmosis, and third one is imbibition. These three processes are responsible for water release out from the lips to outer atmosphere. Got it? Clear? Okay. Then come to its definition. Diffusion. Diffusion, you know, the solvent move from the where? Solvent or gas or solution, whatever. Solute, solvent and gas. Moves from the higher concentration region to lower concentration, and in diffusion cases there is no any barrier. Okay, and osmosis, there should be must be present any barrier or something partition, and here solvent move from the region of high concentration to lower concentration. Concentration, the region same, higher concentration to lower concentration in both of the case. Remember, okay, from the higher concentration to the region of higher concentration to the region of lower concentration. Okay, but imbibition is quite different. Here the absorption occur. So imbibition is a surface phenomenon. Imbibition occur in the form of adsorption type. Absorption. Okay, adsorption. Already I already told about that. Adsorption is a surface phenomenon. Okay, suppose cell is here, so the absorption occur up to cell wall level. It not absorbed by the whole cell. Okay, in case of imbibition, if imbibition occur, then only cell wall or what? Cell wall or the other four layer of the cells, the cementing layer or other layers are what? Absorbed by the cell, not the inner side of the cell. Remember. So here what happened with these three process, two spaces, already I told the spaces, the cell spaces, that is one is intercellular and second one is intracellular. Okay, so what happened in case of osmosis and diffusion? Remember, in case of osmosis and diffusion, first two are the two processes are interlinked with intracellular spaces. Why? Here what happened? Suppose take some cell here. Okay. So what happened here? Wait. Suppose first type of cells are there. So in case of intracellular spaces, suppose osmosis or diffusion, whatever the case, when solvent or water travel, they travel from higher concentration to lower concentration. Suppose water travel to first here. So in first, second, third. Suppose this first cell now filled with water. Okay. So when it filled with water, here the concentration level is what? High. The solvent concentration level is high. So it's automatically moved to the lower concentration area. Okay. Now this this number one cell become what? Flaccid. And second condition is turgid. Got it? Likewise happens again if it's again what happened, second cell is just transferred to, or the solvent moves to transfer or moves from the high concentration region to its lower concentration region. Clear? Okay. So in this manner what happened? It travels from cell to cell. The solvent for travel to cell to cell. That means here the space between the two cells is known as the intercellular spaces. Okay, if the solvent or water travels through cell in between the two cell or cell to cell, then it is under on what? Intracellular spaces. Intracellular spaces. What about the case of intercellular spaces? If the solvent or the water travel in between, here inside the cell, solvent or water, whatever, okay, it moves inside the cell. But here in between the cell, if travel, then what happened? Suppose likewise it's travel. There's some gap are there. Okay, likewise. So in this case, intercellular spaces. These spaces are known as intercellular spaces. Remember, these spaces are known as intercellular spaces. So in this case, what happened? Imbibition occurs. That means when intercellular spaces, when the water pass through the intercellular spaces, that time imbibition occurs, because when the water travel between the two cells, there must be chances the water absorbs on surface level. Okay, surface level, that means cell wall. Here water moves from cell wall to cell wall and in between that. Okay, this is some fundamental thing about these processes. So now let us stop up to this. Then come the second point. This one the first point. Okay, now come the second point. So in case of transpiration, what happened? When the diffusion and osmosis occur, here they just follow the rule of intercellular spaces. But it finally reaches to the substomatal region. Substomatal region. Then to stoma. And then atmosphere. Okay. And here what thing are moving from one region to another and one space to another? That is water or solvent. Solvent in the form of water. That to water vapor. Okay? Okay. Same as in case of diffusion and osmosis, both of the process, what happen? Water just passes and finally reaches to the substomatal region. Likewise, in case of imbibition, they passes through the intercellular spaces and finally reaches to the also substomatal region, then stoma, then atmosphere. It releases out from the atmosphere. Clear? Okay. Then third thing is important point. What? Diffusion and osmosis. Here, when diffusion occurs, suppose one cell, here cells are there. When diffusion occurs here, or here what happened? The solvent moves from high concentration to lower concentration. Okay. When it filled of water, first, second, third. Now suppose here again I draw this. 1, 2, 3. Suppose this cell is filled of water. Okay. So here what happened? Now this first cell is in our higher concentration and nearby cell is lower concentration. Automatically moves from this area to this part, this cell to this one. Okay. So which condition is moves from the one cell to another. Here what happened, due to due to turgidity of the cell. Now the cell is got turgidity. The cell is full of what? Cell contain what? Cell contain solvent or water. That is excess amount. When the cell contains solvent or the water in excess amount, they become turgid. Okay, the condition is known as turgid. Due to turgid, it exerts a pressure to cell wall. How? Likewise. Okay, it creates a pressure to cell wall that is known as turgor pressure. Turgor pressure. Clear? The moving the excess amount of solvent from the cell, in the cell, it become turgid. Due to turgidity, it exert the turgid. It produce the turgor pressure inside the cells. Clear? In case of diffusion. Okay, then come to about osmosis. If osmosis occur, what happen? Osmosis, likewise same thing is happen here also. Water moving from higher concentration to lower concentration. Okay, when osmosis, so here what happen? Osmosis occur. If osmosis occur, this condition what happen? A pressure exit. Here the pressure exit by the cell, that is what? Osmotic pressure. That means in diffusion, that is turgor pressure develop. Turgor pressure develop, and in case of when osmosis occur, then what happen? Osmotic pressure occur. Osmotic pressure occur. Okay. So for this pressure, what happened? Also one extra pressure also done by the cell, that is DPD, diffusion pressure deficit. Okay. So cell simultaneously done diffusion, osmosis and imbibition, but always percentage of process is more in case of imbibition. The transpiration, in case of transpiration process, the water evaporate from the lip to the atmosphere. The imbibition is the most cases where it happen. Okay, through imbibition, water release from the stoma to outside. So diffusion and osmosis percentage is very less than imbibition. Imbibition is the high in percentage. Okay. Also, so next about the pressure here, TP, turgor pressure, OP, osmotic pressure, and DPD. These three pressure creates water to these three mainly create water to forming water vapor. Water vapor form due to this three pressure. Okay, due to creation of the this pressure is create the pressure on water to form is water vapor form to release out. Now finally release out the atmosphere. Clear? Okay, this important three things. Now for case, in case of all total case, what happened? Diffusion occur. The short summary: diffusion occur. When diffusion occur, then diffusion exerted pressure was turgor pressure. From the turgor pressure, water convert to water vapor form. Okay, due to pressure, water is in now water vapor form, and finally it reaches to the what? Soft stomatal region. Okay, and then it goes outside. Clear? And again, like osmosis, it also produce a pressure, that is osmotic pressure, and then it convert the water to water vapor form, so that it now substomatal result to outer atmosphere. In case of imbibition, what happens? In case of imbibition, when occur, simply it travel through the cell wall to wall. Okay, and cell wall, it just absorption occur, or the water, the solid moves from the cell wall to cell wall, and in between the intercellular spaces, and finally reaches to the what? Travel to intercellular spaces, and then substomatal region, reaches to stomatal region, and then just out from the atmosphere. Okay, why it out to atmosphere? Because the pressure or the water vapor pressure is more than the atmospheric water vapor pressure. That means water vapor percentage in the atmosphere in that time is very low than inside the cell. Okay, due to continuous process, here the water vapor inside the cell is more than the here atmosphere. So easily water vapor is released out to the atmosphere. So here up to this is clear. Okay, now come to its increasing and decreasing level. Okay, here the osmotic pressure develop, turgor pressure develop, DPD pressure also develop. But what about its pressure? About the decreasing and increasing. When three things are developed from the osmosis, osmotic pressure are developed due to osmosis, and due to diffusion, what happened? Turgor pressure developed. So here, and one extra thing is DPD. Okay, so what happened when OP and TPD increases? DPD is decreases. Okay, due to OP and TP increases, its pressure DPD now decreases. When such type of condition are formed, then water from the water vapor form, and then it release the water to where? Intercellular spaces, and finally reach to substomatal region, then to stoma, and finally remove out. And during removing out, here the water vapor, here decreasing of the water vapor also occur, but here the level come to the level of water vapor in atmosphere and inside the cell. Here the inside the cell water vapor percentage is more than the inside the cell water vapor percentage is more than the atmosphere. That means here the inside the cell, here the inside the cell, up to this inside the cell, atmosphere outside the cell. So here water vapor is more, so that it automatically moves to atmosphere. That means atmospheric water vapor is very less. Clear? Okay, this is all about the release out of the water vapor. But how the stroma are open, that's a separate process. Okay, here the water vapor how moves and how water vapor convert, water is converted to water vapor, only explain those of the things. But how the stoma open and then water vapor release out, that's a other process. That process is known as opening and closing of stoma. That is first opening, closing the separate thing, opening of stomatal pore. Okay, and that's a separate process, and I will discuss about later. If you like this video, please hit the like button, share, comment and subscribe the Botany World. Thank you so much.